Hey guys, it's Mr. S, and today's topic is about solids, and especially I'm going to do two types of solids, prisms and pyramids. Right. So today's goal is to introduce two types of solids and understand what the volume is, and looking at the relationship between the pyramids and prisms. Right. So here's the my definition, my description of volume. It's the how much space inside a solid figure, the 3D figure. So last video I talked about area, which was 2D, the plane, but now we're moving into a volume. It's a solid. And the unit used are something cubed, or sometimes it says like cubic something, like inch cubed, centimeter cubed, feet cubed, or like cubic centimeters, cubic meters, cubic inches, cubic yards, whatever, right? So here's the first one that I'm gonna do today. It's a prism. It has two parallel faces called bases, and other faces are parallelogram. So here are three different types of prisms. This one, let's look at the red one. On the top it has a triangle, and on the side it has a rectangle, and you can't see here, but let me exit out and I can move this kind of, yeah, like this, and you can see that at the bottom you have a triangle, top triangle, and the other like side of the faces are rectangles. This solid is called triangular prism because of the shape of the base. These two bases, the triangles, they never meet, even if you extend the shape. No matter how much you extend, these two faces called the bases never meet, and that's why it's parallel. Usually the prisms are named after its bases, this shape of the bases. So this is the triangular prism. So this one will be rectangular prism. It has a rectangle on the base. Here's the top, and you can see here's the bottom. I know you might be thinking, hey, what about this way? You know, look, this as a base, this as a base. Yeah, you can do that. It looks like a square though. Now, yes, but it's still a rectangular prism. You've probably seen this before. All 6 sides are squares. It's a specific type of rectangular prism called cube. And that's example that you might see on this cube is a dice. Right? You know, you roll a dice and you play a board game or whatever. And other examples of prism will be cubes like this, or books. Like books, think of it as a like a paper stacked up, and then you have a big rectangular prism. Alright, let me go to the slideshow, and alright. So when you are asked to find the volume of a prism, it'll probably say base area times height. Now I didn't say length times width times height. I didn't say that because it could be triangular prism and you don't know where the length and width is. Alright, so base area times height. So you find the base area, in this case it's triangle, and you multiply by its height. If it was a rectangular prism, think of it like I said before earlier, stacked paper. Like the paper, those plain one sheet of paper stacked up, and you make a big pile of paper. You know, the paper itself has length and width, and by stacking up you create a height. Right, so that's the prism, and the next one is pyramid. It has one base, not two, and other faces are triangular, meeting at one vertex called the apex. So let's look at this blue one, dark blue one. Its base is rectangle. It looks square, but I'm just gonna say it's rectangle, and it's a rectangular pyramid. let me exit out and look at this, rotate it, and you can see that all other faces are triangles and they meet at this point right here, this vertex. It's called apex. Let's look at this one, the light blue one. As you can see, all of the sides are triangles, so I'm just gonna pick this dark shaded part as a base. And yeah, like I said before, it's triangles on the other faces meeting at this point. It's the apex. Now, the examples of a pyramid will be pyramids that you might see on that exist at Egypt and Mexico and other countries. Right, so let's go back to the slideshow, and then the volume of a pyramid will be 1/3 times base area times height. So you find the base area, in this case it's a rectangle, multiply length and width, and then multiply height. Now don't think the height is right here. Earlier, like I said, its height is from, think of it as from this apex bottom straight down to this base. Draw a line from this apex straight down to the base. Make a 90-degree angle right there with this line and this base. Kind of like a person standing up in the base, you know. And that's the height. Now, where did that 1/3 came from? Well, why is it 1/3? You know, base area times height, that's the formula for the volume of a prism, but it has 1/3 in front of it and makes it volume of pyramid. There are different websites, videos that explain this. One of them is fill up, like using a sand or something. You get a pyramid and you put sand inside and you pour it into the same base area and height prism. And you keep pouring it in, you fill it up, pour it, you know, and fill it up, and then pour it in, and then see how many times you need to pour it into the prism. And the other explanation was 6 equal parts. You get a prism and you divide that into 6 equal prisms. And you look at the volume of a prism, and then from there you can get this formula. Now I'm not going to do that today. And the thoughts for 3D shapes in general, just one thought. It should be like one thought. Now, having actual objects when dealing with these solids, because many of us struggle with imagining, like I do, imagining inside the head, inside a screen, in the book. You know, looking at 3D figures in the 2D plane, it's very difficult. You actually want to have something in hand. Like, I don't have something in my hand right now, but just have something in hand that actually represents it. Like, so when you're like a child, like 1 year old, you know, you give those toys, those blocks, right? You can get that and provide it to the students and use it as an example of prisms or pyramids or whatever. And then look at the volume or surface area or whatever. So maybe not have one for each student. You might not have enough. You can do like one per group, or like pass it around to the class, or you can put the shapes in different stations around the classroom and have students walk around as they do the calculation or whatever, or exploring or whatever. Right, so that's the end of the video today. If this video was helpful, please like, leave a comment, and subscribe my channel, and I'll see you in the next video about some kind of solids or areas. Bye bye.